Okay. Okay, can you hear?
Okay, all right.
Alright. So we continue to the topic. So I'm to introduce myself. My name is Dr. Muhammad Saiful Samsudin. I'm graduate in doctorate in University Sultan Zainal Abidin, Terengganu in environmental toxicology, and I'm also having my master in University Putra Malaysia, also in environment analysis and modeling. So and now I'm a certified trainer under HRD Corp, and I'm also as a trainer in SOE Sdn Bhd. So you all can check my Google Scholar here. So you will you want to know about my previous article about my research in environment. So we go to the topic multiple linear regression. So you know about regression or have any idea about regression?
Most of the time we know
Hello?
about linear regression, single regression, Dr. Saiful.
Yeah. How about the others? Already use the regression method, or this is your first time? So
No,
okay,
we have
I
background about the regression, but not about the second part
multiple
of the. Yes.
artificial neural network, right?
Yes, correct.
Okay. So okay, kat sini we will understand first about regression. So later on, when we learn about artificial neural network, you will get the picture how these two method related with each other, because we want to make a prediction model using these two methods. So we will learn today about the regression first. So what is multiple linear regression? So we know that regression method is have a dependent variable and described by the set of x independent variables. So y kita perlukan beberapa x untuk independent. So maksudnya y ini bergantung pada set of independent variables. Right? Okay, so the first thing we must understand, we need to know the relationship between a single method dependent variable and two or more method independent variable. This is a multiple linear regression. If single linear regression, we just want to know about the relationship between a single dependent variable. So we have two or more independent variables. So boleh kita explain beberapa parameter dalam environment. Kita ada beberapa parameter. Kalau you all guna data dalam udara, kita ada beberapa parameter, dan dalam kajian dalam air pun ada beberapa parameter. So kita boleh gunakan variable ni untuk kita tentukan apa yang kita mahukan dengan hubungan di antara parameter tersebut dengan apa yang kita dependent variable kita lah. So that one we want to learn today. Okay, so regression analysis. Okay, this one formula about regression. So I don't want to talk about the formula here because disclaimer, I am not a mathematician, but I am applied the mathematics in my research, my previous research. So if you want to know why is using Y or why we using beta, I just cannot explain to you about the mathematical ways, but I will explain to you more layman here. Okay, so regression, Y dependent, we can see here, so Y is connected with this 3x, x1, x2, x3. So this 3x, we call it independent variable. So when we link these three, we will connect it with this Y. Okay, in bahasa, secara lebih mudah, dengan menggunakan tiga independent ini, kita dapat tentukan nilai dependent kita, iaitu Y. So maksudnya dekat sini, di sini kita ada relationship between variable kita dengan apa yang kita perlukan. So saya akan explain lebih terperinci tentang ini. So we know that this have a correlation with the dependent variable. So okay, it's clear about the formula about regression. May I continue?
Yes.
Alright. Okay. So common type of analysis. Okay. So what is the common? First we compare group. So as I know, all of you or some of you have already familiar with the comparing group analysis. Like we have here is chi-square test or analysis of variant or ANOVA. All right. So the second type of analysis is examine strength and direction of relationship. So we have bivariate Pearson correlation. So the R value. We want to know the relationship between one variable with another, and then we have a multivariate. We can see a multiple regression analysis, which is between relationship between several independent and the dependent variable. Okay. Okay. What does regression analysis do? Okay. Is more like to know the relationship between independent and dependent, like I said before. So we will link the changes and values of one or more other variables. Right. So the difference between linear regression and multiple linear regression. Simple linear with only one explanatory variable, and then multiple regression have several. So I want to emphasize that simple and multiple is almost the same, but we use, if multiple, we have more dependent variables. So we can get the idea about the regression. So here we have bivariate of simple regression model. So in simple regression model, here is X come to Y. When the research about education, how will education can have a relation, what we call it, hubungan, relationship to the income, gaji. Jadi kita gunakan simple regression. So if have a multiple regression model, we have education, such experience, age. So we can what we call it, have to know the relationship between this dependent to know about the Y income. So this is what we call it, a basic or simple example here before we go to the main topic in environment. So okay, this is not important, I think. Okay, Okay. Okay. So when we use the multiple linear regression, we will get the the tabulation of our data. So from the data, from the scattered plot, we can get the best fit line. So when the best fit line, we will have the best model to use for prediction. So the best fit line is the least square method to identify the line, and the line called the square regression line, and the method will minimize the SSE, sum of square error. All right. So okay, the next one is type of regression model. So we have when we get this graph, we know that it's a strong positive relationship because the data, the tabulation of that is near in the straight line. So if we get this graph, we can get almost the perfect model and we can use it as our prediction model. So we have the second strong negative relationship. Dia opposite the strong positive. When X is low and the Y is high, so we get the strong negative relationship. There is no relationship. So there has several research. They use the variable or parameters to want to know the relationship between A and B, or several variable with the dependent variable, but there is no relationship at all. So if they want to use this method to get the model will not successful to use for their research because there is no relationship, so there is no point to use the model. Okay, maksudnya kat sini apa yang saya cuba sampaikan, bila data yang digunakan ataupun dia nak memerlukan hubungan di antara beberapa parameter dengan apa yang dia mahukan tu, tak ada correlation, tak ada relationship. Jadi model yang dibuat itu tak ada langsung dapat dicapai. Jadi inilah no relationship. So we will see the the process after we make some exercise later. Okay. Okay, first we go for the first exercise. Okay, I believe one have sharing with you. Okay, do you know your Excel can use for statistical analysis, or have you done it before? Or what type of what kind of software do you use before? May I know?
Excel
Or
stat.
everyone here use Excel before?
Excel.
Excel stat. So you all familiar with the Excel to run the analysis?
Yes.
Okay, so it's
The
easy
GMP,
lah.
no.
So,
It's the first time to know that the existence of GMP.
alright. Okay, so it's okay. So let me continue. So do you know analysis toolpad in Excel?
No. A toolpad, I guess.
Okay.
Saya pernah dengar. Yang ada boleh
Okay.
analyze terus .
Yeah. So if
Okay lah, ada.
some of you maybe is first time know about the toolpad add-in, so I will show to you how to activate the analysis toolpad add-in in your Excel. Okay, so everyone already open your Excel?
Kita nak buka.
Alright. Dah buka Boleh minimize, so boleh tengok sekali dalam slide. So we go. So in Excel, you go to the then file, and then you click option. Alright. Okay. Get?
Okay.
Alright. So okay. So in option, you go to the add-in, and then you find the analysis toolpad. And you click at the analysis toolpad, and then you click go. Alright. And then we'll show a box add-in, and then you choose analysis toolpath, and then you click OK. Okay, so here you can see at the data, and at your right you see the data analysis. Okay, got? So from the data analysis, you can click, and then it show a box about several statistical analysis in Excel. So you can use this for your data. All right. Okay. So okay, let's we do it together. So you at the data analysis, you click the regression. Okay, data analysis. Okay, you find regression. Here, regression. Okay, and then input Y, you put house in price as a dependent variable, and input X as square feet. Okay. Then don't forget to click the labels, so the labels not included in our analysis. So if you want to put a confidence level, you can put 99% or 19% or 95%. It's okay, up to you. And then you click OK. Okay. Everyone get the, or I'm too fast?
Dr. Saiful, the participant requests to repeat again the step.
All right. Okay. So we go to the. So if I'm too fast, make sure you tell me, or tell the organizer. All right. So we go back. Okay. First, if you don't have the data analysis, you can see here you don't have this one, data analysis. So how to activate this tab? Okay, we go the step one by one. Okay, first, okay, you go to the file, and then you click the options. Okay, Okay, in a Excel option, we have several like general formulas, proofing. So you just go to the add-ins, okay, and then you find analysis tool pack. Saya rasa semua orang ada analysis tool pack. So, okay, clear here.
Clear.
Okay, clear. Okay, good. So when you click this one, then at beside the manage as add-in, you all click go. Click go, and then it's show a box, add-in box, and then you all just click analysis tool pack and okay. Right? So you all already activate the data analysis in your Excel. Semua orang dah dapat ke? Is it everyone get this data analysis?
Okay. Got it.
Okay. Alright. Alhamdulillah. Alright. So in data analysis, we have several analysis tools like ANOVA. You can use ANOVA two-factor replication. You have a correlation here. Also, you can get the descriptive statistic. It's all in your Excel. So believe me, I want fun fact. My master and PhD, 80% I use Microsoft Excel as my statistical analysis for my research. So I don't use SPSS. I don't use any kind of other software. So I just using only Microsoft Excel for my analysis. So here we got not few, but we got so many analysis. You can see. You also can use t-test. You can use regression, of course, and histogram. So it's all in your Excel. So if you say you don't have a software or you don't have a tools, or it's very wasted lah, because you all have the Excel in your computer. So after this, you can analysis just using Excel. All right. So okay, we can continue. Okay, you go to the data set, the example one data set. So this is not the environmental data, but I want to show you the basic of the regression first. So we have a house price in $1,000 as our dependent variable, and we have a square feet in X, square feet of house. Right? So how can we use these two variable to come up with the regression? So first you go to the data analysis. Wait. Data analysis, and then you go to the regression. You will find the regression and this regression, and then you all click OK. Okay, am I clear? All right.
Yes.
Yes, yes.
All right. All right. So you put the Y input Y here in house price, and then you input X. You click. You select all the square feet data of square feet, and don't forget you must click the label. So the analysis will exclude the title, the label here. So this going will also the label. So we must put click the label. So also if you want to label, you want to know the live plot, just click to show the basic of regression here. So you put the confidence level 25%. It's up to you. If you want to put 99%, it's also okay. All right. So then we can click OK. All right. So we got the result here. So we want to get this result. Semua orang dah dapat ke?
Okay, dapat.
Yes.
Okay.
Dapat,
Ada yang
dapat.
lost?
Yes.
Okay, Alhamdulillah. Okay. Alright. So here, the output, we get the multiple R 0.7, R square 0.58. Okay, what is all this about? Saya akan ceritakan. In regression, we have the ANOVA result. We also have this one part. So I believe all of you get the same numbers or same result with this slide, right?
Yes.
All right. Alhamdulillah. Okay. So how can we create? We want to make this result as our model in regression model. So you see here, y equals to a plus b1 x1. So the house price as a y, because we put the as a dependent variable, and then a is intercept between x and y. So we got the coefficient as here is 98.24833. So we put a as this, and then plus b1 as square feet. Square feet. And 1.7 cost. As with square feet. Square feet, the anything we want to predict. Okay, we go. Okay, so you already got your regression line and scatter plot, and also you already have your regression model here. So from this one, we will know the house price just using this equation. So if you don't have the square feet, using this the of house price, but you got the square feet data, so you can predict the house price just using this equation. Okay, is it clear? The house price model. Okay, let me repeat. Okay, from this result, we know that the regression formula is y equals to a plus b1 x1. So in this case study, we want to know the house price, the house price model. So if you don't have the data of house price, but you know the already have the square feet data, so you can use square feet data and put in this model, so you will predict the value of house price. All right. So when we see our data here, Okay, so if we don't have the value of house price, we can use the formula to put in this what we call the missing data by just using the square feet of data. Alright, this is our objective and this is our intention to make the regression part here. Alright, so I think I will continue. Okay, so this is the estimated average value of y when the value of x is 0. If x is 0, it's in the range of observed x value. Okay, you can read here. Here, no houses had a 0 square feet. So, B0 just indicates that for houses within the range of size observed, 98,000 is the price of house price not explained by square feet. So, it's unlogical because if square feet is 0, we just got the 98.24833. All right. So we will measure the estimated change in the average value of y as a result of 1 unit change in x. Okay. Do you understand what is interpretation of this slope coefficient? Or it's very what we call it confusing ataupun susah untuk difahami the concept of the model. May I know? Saya takut saya salah explain je ni, takut tak jadi confused.
Okay, Doktor, no problem.
Okay, no problem. Okay, Alhamdulillah. So, okay. Okay, we get back to our data. So the estimate regression equation, just like we already know that the house price model equals to 98.2.5 plus 0.1098 from our output before. So how to predict the price for a house with 2,000 square feet? So we have here until we don't have a 2,000 square feet. So how will we know if the square feet is the value the square feet is 2,000? So we just put the value of 2,000 in the square feet here. So when we calculate, we get the house price for 2,000 square feet is $317.85. All right. Oh, sorry, times with 1,000. So 317,000 here. So this is how you can use your regression as a prediction tool. This is a basic. This is just a single regression. So what if you when you use it to your own data? For example, from my previous study, I use prediction for my in water quality. So I have a very lot of data, almost 1,000, because my study is about marine water quality in Peninsular Malaysia. So I gather a secondary data and the primary data. So I get a lot of data. So what if my second data have a missing period, which means from a several station, there are no result or no data from that time of period. So how can I run my the next analysis if I not what we call it, we may not counter the problem. So this come for the regression part. As long as our regression model is very good, very fit, so there is no no problem if we use the model to put in the missing data. Okay, faham ke apa yang saya terangkan? You understand what I'm saying here?
Yeah.
So
Faham.
okay, alhamdulillah. So that is the best part of prediction model. So you don't have to what we call it, stress, or you don't have to what we call pening-pening kepala because of you don't have problem with your data. But in this part, you not cheat, but you just manipulate the data by using in the right way. So when you use this part, so there is no problem because you predict the most probability of what happened in your missing data, right? Okay, so this is a gist of regression. I hope you understand the first part, because when we go to the exercise, we can see the real of the data, so you know how to what we call to use the regression. All right. So okay, we continue. Okay, the most important in prediction model, either you are using the MLR or you are using the ANN. This is the coefficient of determination. Okay, this one will what we call it, give you the what we call the best for your model, because the more high of R square, the more precise and the more accurate your model to predict your data. So if when your R square is low or give negative value, so there is no point of model, right? So not all data you can model it, because if you got for example, R square equals to 0.1, so the prediction will not supposed to use in your data, because there is no significant, there is no relationship at all, there is weak relationship. So if you want to predict, there is no point, because it gives you the wrong or is far from the accurate value. Okay, so we can see after this. So R square is SSR, sum of square explained by regression, divide by SST. SST is total sum of square. Is already in your output before. Okay. In the single independent variable case, the coefficient of determination is R square equals to R square. Coefficient of determination equals to simple correlation coefficient. So we can see here, regression and correlation have a very correlated with each other. So when you use the correlation method in your data, so you know how strong your variable relationship between your variable. If it have a strong correlation, it will give you a high chance of high score of R square, coefficient of determination. So you also get the point, what we call it, awak semua dapat gambaran yang hubungan di antara variable itu memberi kesan yang baik kepada model anda, ataupun when you use the very good correlation between two or more variables, it will give you more accuracy or more precise of prediction model using MLR. Alright, so So this is approximate R square value. Okay, before we continue, okay, this is clear about this one, coefficient of determination.
Okay, Dr.
Dr.
Clear.
Amal, okay, clear. Alright.
Yep.
Saya
Dr.
takut saya terlalu
Saiful,
laju sebab dah habis. Ya.
can you
Sorry,
click that,
Mr. Wan.
Dr. Saiful, can you click that hide button there?
Oh, okay. Sorry.
No, I just try to
Okay.
aja nak bagi kelakar sikit.
Alright. Saya takut selalu laju ni. Itulah. So if you understand,
Okay.
just interrupt or ask in the chat box. Okay. So saya takut saya short sendiri je. Okay. So we continue. Okay. Approximate R square value. Okay. So if R square is 1, it's a perfect line relationship between X and Y. 100% of variation in Y is explained by variation in X. Like I described or explained to you from the previous slide, if you get R square equal to 1, so your regression is very 100% same as the predict and the actual. So it's almost impossible, but we can get the nearest to 1 if your data is good and have a relationship between X and Y. Okay, so when this one 0, okay, less than R square, less than 1. Okay, weaker linear relationship between X and Y. So we can see in the scatter box, the scatter plot here, the tabulation of the data. Some but not all of the variation in Y is explained by variation in X, right? So which means this is a common to our data when we use the regression. Some but not all of the variation in Y is explained by variation in X. If we get the R square value is near to the 0, so it's the weaker the linear relationship. If we get the R square value is near the value 1, this is more stronger the relationship. So we in our data, commonly we get this one. But if R square equal to 0, no linear relationship at all between X and Y. So the value of Y does not depend on X. None of the variation in Y is explained by variation in X. Alright, okay. So which means if you have a data but there is no relationship at all. For example, you have a house price, but you want to know the relationship between house price and a size of a car. So there is no relationship at all. So it's same with your data. So if you want to see the water quality, as example, water quality index, you just have a variable about about turbidity or we call or anything, but is that does have no relationship. So if you want to put that as your model, it's not necessary and just waste your time. So you just focus on the other variable which have a more strong linear relationship, so you can get the best model you can have, right? So this first part is crucial because I have a student asked me to want to make a model for his data, but there is no relationship at all. So I suggest to him, you don't have to put this analysis in his research, but he's hesitant and want to put it in his research. But after all, we just get backfire to him lah, because in his viva, the examiner asked him why you put this, because there is no relationship at all. Just want to what we call it, unnecessary in his study. All right. So okay, we go back to our output. So R square, how we get this 0.58082? So SSR divide by SST. SSR here, SS, we can see the SS in the ANOVA box. So SSR, SS regression, 18934.9348 divide by SST, SS total, 32,600. Okay, divide by it, and we can get the R square value, 0.58, which means 85% of the variation in house price is explained by variation in square feet. Bahasa mudahnya, maksudnya 0.58 yang menceritakan tentang variation data house price dengan square feet. So from this R square, we call it moderate relationship. So when we have a lot of data to predict, but it will not get the best of model or prediction value, because if this one is 0.9, we get the best of the model, right? So standard error of estimate. The standard deviation of a variation of observance around the regression line is estimated. Okay, this one I think is not necessary to explain. You can read after this. All right. Okay, descriptive of MLR. Okay. Okay, before we continue, so you semua faham we understand the basic of the regression or any question before we continue? All right, okay, so we continue. Okay, so descriptive of MLR, derive regression and prediction equation. How to identify B0, MB1, B2, and BP. So information of MLR, assessing the goodness of fit, the regression. So we got if we get the regression model, F test or the slope in T test. So it is all about the hypothesis, all right? Which means we state the null and alternative hypothesis. Okay, this is the basic of the statistical model. We have a H null and we have the H alternative. When the regression model does not fit the data, is H null, and if the regression model fit the data, is H alternative. So deviation read significant F, and we can conclude. Okay, what this is all about. We can see the regression model fits the data from our output. All right. So I believe all of you have very expert and very familiar with ANOVA or hypothesis testing, right? Or do you just have don't know the hypothesis testing? May I know? Boleh saya tahu macam mana semua? Semua dah tahu tentang hypothesis testing? Yeah.
Yes.
Alright.
Yeah.
So, okay. So how we want to know the regression model is fit or does not fit? We focus on the hypothesis testing. So we go back to our data. Sorry. Before that, when we want to reject H null, if the significant F is lower than alpha. When we want to fail to reject alternative, or we accept the H alternative if the F is more or equal to alpha. All right. So we go back to our data. So this one. So we know that F is more or less than significant F. Hello. F value is more or less than significant F. Oh, I'm disconnected. Okay.
Okay.
Online.
Yeah.
Alright.
Good.
Alright, okay. Okay, so from the data, from the result, we get the F is more than significant F, which mean
Accept.
this one,
Accept.
right?
Okay. Okay.
Yeah. So we fail to reject H null, but we accept the H alternative. The regression model fits the data. So we can use the regression model for our data. So this is just for the hypothesis testing, and we want to make sure is it possible to we use the regression model. If we get the, for example, R square is 0.000 something, so it must be the F is less than alpha. So the result will get the regression model does not fit the data. So we just don't want to waste our time to use the regression model in our data. All right. So this is the what we call it justification to use the regression model. So I'm not explaining to you for the mathematical jargon or theory. Just want you to know how to apply this mathematics to your own data. So you will more understanding the what want to apply. So you get the picture or the explanation in your study or your research or your thesis. Why you use this kind of model, regression model, even you use the single linear regression, or you use the multiple linear regression. This is the most layman I will we explain about the regression. All right. So it's same with the this one. Okay. Same with the this testing with the t-test. If we use the t-test, same also. If t is less than alpha, we reject H null, and if t is more or equal to alpha, we fail to reject null. Alright. Just the same with the F. Okay. Alright. So let's see.